Welcome to this Frequency Matters podcast. I'm Pat Hindle, and today I'm talking with Brian and Subbaiah from Copper Mountain Technologies. Welcome, guys.
Hello,
Good to be here.
great to be here.
So maybe you can introduce yourselves, maybe tell me a little bit about what you do at Copper Mountain. Brian, how about you first?
Sure, I'm Brian Walker. I'm the technical person working in marketing at the moment. I create technical content for some of our trade journals, write articles that end up on our website, and I also get involved with some tricky customer measurements, little things that are a little bit off the wall. I've been in the business for about 40 years, so I'm our subject matter expert here at Copper Mountain Technologies.
I've actually seen many of your videos. They're very good, very instructional.
Thanks.
Absolutely.
Subbaiah, how about you?
Yeah, so I'm Subbaiah. I've been with Copper Mountain Technologies for over 9 years now. I'm the Director of Technical Solutions here. So I'm responsible for applications engineering, service, that's repair and calibration, and also production assembly here in Indianapolis as well. So a couple of roles, but yeah, I oversee various departments here in Indianapolis.
So I can see I have the two best technical experts here, so it should be a good discussion.
Yep.
So maybe we can start off with, what are some of the new product trends you're seeing in the market these days?
Yeah, thank you. I'll field that one. So our focus lately to address the some of the emerging trends has been to focus on SWaP C, size, weight, power, and cost. We find that a lot of our customers are focused on smaller, more agile solutions, things that they could perhaps bolt into their system or can be easily transported or be used in their military applications, certainly, and commercial applications for both. So we've created a number of 1 and 2 port modules. So here's a 1 port VNA ready to bolt into something, and we can mention some of those applications later.
What's the size? What's the size of that about?
Oh, that's about 2.5 inches by 1.5 by 3/4. Yeah, very small and very light. This is a 5.5 gigahertz VNA, and this is a 2 port VNA. And here is a full-featured 9 gigahertz 2 port VNA. And this is basically the same as our desktop 9 gigahertz SC5090, I think. So it's a fully featured lab grade measurements in a module that you can put inside of something.
So that's about 6 inches by 6 inches by
Yeah,
3/4.
Yeah, about 6 by 4 by about an inch if you include the heat
Wow,
sink.
that's impressive.
Yeah, it's crazy. I think it's just about the smallest 9 gigahertz VNA that you could get.
Yeah.
It gets a little warm. It has a heat sink, and you put a little airflow across it, and you're good to go. So this is ideal for many applications like test sets and things like that. So Subbaiah, you were going to talk about the lab, right?
Yeah, so yeah, we have an ISO 17025 lab here in Indianapolis as well as Cyprus. We take metrology very seriously. So all the units that are newly produced as well as the units that come back from customers for periodic verification go through rigorous verification procedure. So all the reference standards that we have in our lab here are traceable directly to NIST, PTB, and other reputable international institutes. And also our lab is accredited up to 54 gigahertz. And the parameters include frequency, power, reflection, and also transmission accuracy capabilities as well.
I think the main reason why we wanted to mention that
Mhm.
was that these modules, as small as they might be, are fully metrological VNAs.
Still, yeah.
And we're able to verify that with our lab here.
Yeah.
So these are not toys.
Yeah.
So yeah, those are impressive size-wise. So, what are the typical applications that you'd use these modular VNAs for?
Yeah, because of these compactness, we have seen these modules being integrated into varieties of innovative systems. out of the many fields, I would say material measurement and detection is probably the most popular space. There are a lot of research done these days in military, in agriculture, medical, and various other fields. So they're looking at millimeter wave, microwave, and RF regions to understand the material properties. So these devices are typically embedded into a system. So it could be like a handheld scanner, it could be drones, it could be mounted on a robotic arms, and even we have seen them being embedded in unmanned toy vehicles as well. So a lot of applications, and there it could be either one port or two port, or we've even seen multi-port measurement capabilities as well with these. And so all these various forms, they're used to understand radon properties, water content in fruits, soil moisture measurements, and also measuring water and snow depth, and measuring pipes and various applications.
Some imaging
And
applications.
imaging applications also. And I think Brian has worked with customers in the the moon
Yeah,
application.
we actually have one of our modules. I think it's one of the earlier one port modules, not quite as small as this one. But we have one of our one port modules actually on a lunar lander that is presently on the moon. And it was used to measure the amount of liquid oxygen in the fuel tank. A difficult thing to do during weightless conditions. Clearly, if you goose the rocket, and you could make it all go down to the bottom, and you could have something that could measure the level. But they wanted to be able to measure it while it was weightless and have little globs of liquid oxygen floating around. So they devised a method of actually doing that using a one port VNA. So NASA Glenn, I think, actually did that work.
Yeah.
And it got designed in.
Yeah, and also there are some application notes and videos on our website. I say some because we have NDAs with most customers, so we don't have it fully published anywhere. But there are some references on our website for viewers to see. Yeah.
Good stuff. So you had to probably address a lot of integration issues. What were some of the specific challenges in the product integration part?
Yeah, because they are integrated, as I mentioned earlier. So space and heat flows are typical challenges. So right from the get-go, our engineers work very closely with the customer to understand their requirement. So some like it, rectangular, some square, various sizes, shapes. So we basically, during the product definition phase, we work very close with the customers and identify the solution that they need. So that's been one of the things. The other one is also we also help customers extend the performance of the analysis even after launching the product. So because their end users use case might have evolved. And so recently we had a customer who wanted to extend the frequency of the device. So we were able to tweak it by changing some components. And so of course, these are all engineering challenges, but the reason why we were able to work on that pretty quick is because our manufacturing is pretty streamlined. We produce everything here in our office in Indianapolis, and also we even have some vendors who are within driving distance. So that has really helped us with these kinds of cases where customers want us to change things very quick, and we've been able to adapt. And there are other instances with software and driver as well. And we had a military customer who wanted us to change some things. So we were able to work on that pretty quick. And there are other companies who are new to RF and also automation. They could be small. So they wanted our expertise in the RF and automation. So we helped them get to that prototype as well as help them scale. And after that, they were able to take their product onto the market and scale to a next level.
Yeah.
So ultimately, we are here to solve problems, and every case is unique because all these modules are embedded in different types of solutions. So there's no one solution when it comes to this, but we work on case by case.
Yeah, we're able to engage with our customers directly And we're not afraid to do that. And we're, being a smaller, nimble company, we're able to do that and respond and make changes that perhaps they're looking for. At the end of the day, as Subbaiah said, we're here to solve problems.
I have heard that about Copper Mountain Technologies that, you're very customer centric and responsive. So much, it's good to be a small, nimble company and be able to do that and be engaged. So, how is the calibration handled for these VNA modules?
Yeah, so it sort of depends. Like this module here, it has attached to it a Wi-Fi antenna. Um, we calibrate these VNAs at the factory here, and so this is calibrated right here to the output connector, and it will stay reasonably calibrated for a couple of years. So with the factory calibration in place, you could still do your own user calibration if you wanted to, but if you wanted to make measurements and you're okay with a slight error, very small, you can attach this directly to the antenna and make an immediate measurement. So I could carry this around in my pocket, and I have, and take this out, connect directly to an antenna or a cable leading to an antenna, and be making measurements. This is powered by USB. Be making measurements immediately. So in some cases, calibration is not required. One other thing is that we have the time domain capability, time domain analysis capability built into these VNAs at no extra charge. It just comes out of the box. It's ready to do time domain. And in time domain, you don't really need to do calibration. Calibration just moves the reference plane to wherever you happen to want it. So if I had this VNA, a test cable, and a device I needed to test, to actually look at in a time domain mode, maybe another long cable, I could just choose to ignore the first couple of feet, which would be my test cable. And I'm going to see where my test cable makes the connection to my cable under test, because there'll be a little blip there. So time domain requires no calibration at all. So it's a combination of factory calibration and the fact that you don't need calibration at all for time domain is a big plus. And this is able to connect directly. One other thing I might mention is that we have the time domain capability, and along with that comes gating, time domain gating. So if you're using this perhaps with an antenna pointed at something that you need to measure moisture, and you have like this, and you want to measure that thing, and you don't want to measure what's behind it or around it, you can actually set a gate around the thing that you're measuring. So you'll get no other reflections other than the ones that you want. So the analytical features that are built into this help with those measurements, and calibration is pretty easy to do.
So I have seen some cool demos where you've collaborated with a lot of other companies. Can you tell us about some of those collaborations?
Yeah, we've collaborated with several companies in material measurement space. We collaborate with Compass Technology based in Georgia, and we also have SPIAG and Swiss 212 as well. They're located in Switzerland. So our focus is that we are mainly focused on VNA and its metrology. So we partner with other companies to provide that complete end solution. And I'm sure we have a couple other companies. Brian, can you think of?
Yeah, we also not too long ago we began working with Millibox. Millibox makes a small over-the-air antenna test set. It's designed, intended to work with antennas above 18 gigahertz and all the way up to as high as you want to go. Their software drives automated gimbals inside that move the antenna about up and down and around to get your antenna patterns. And it's integrated with our VNA and perhaps Aerovent extenders to get up to the higher and higher frequencies. So that's an amazing system. So if anyone's doing 18 gigahertz antenna measurements, you can do that in a full-size anechoic chamber, but those are very expensive. And if you don't already own one, you're going to want to look at a Millbox solution. And we offer that bundles on our website, so you can put it all together and you don't have to figure out how to do that. Also, we collaborate with people that do load pull. Who's the company?
Mallory and Focus are some of the
Yeah,
companies.
Murray and Focus. I think those are the two.
Yeah.
So they our controlling software in the VNA is compatible with those load pull systems. So Millibox and the load pull guys.
Yeah.
Well, great. It's been great talking with you both, Brian and Subbaiah. And thanks for talking with me today. You know, the trends that you're talking about and collaborations are great to hear, and hopefully can have you back to hear about more developments in the future. To our listeners, you can give us a like and listen to more podcasts at podcasts.microjournal.com. Thanks for listening.
Thanks, Patrick.
Thank you.